In this tutorial we're going to cover graphing cotangent, which we've talked about tangent already a little bit, but I want to kind of go into a little bit more detail with cotangent. So basically cotangent takes the form just like tangent does, except it's going to be a reflection in the x-axis. So the general form of cotangent, let me adjust that, cotangent here, it's going to be just like every other trig function we've been working with. It's going to be a times the sine, or cosine, or tangent, or whatever it's going to be. In this case, it's going to be cotangent of bx minus h plus k. Remember, when we were discussing this in class, we made it a point to talk about that the order of the letters didn't really matter. In this case, if that's B, or if this is H, or sometimes this is called C, sometimes it's used as K. So don't get too caught up in where the what the letter name is, but just in where it's located. And so we can come out with our formulas for cotangent like this. So we have the period, which is pi over b, just like tangent. Remember, that's different than for sine and cosine. Phase shift and vertical shift are just like before. You have negative h over b, and you have k. Now what we're going to do now is we're going to graph this just in its basic form, and we're gonna kind of walk you step at a time. First thing you're going to do is you're going to add in the asymptotes for cotangent. Now I'm going to put in two different periods here. So you can see I've got one at 0. You can see it goes all up along the x or the y-axis here. You've got one over here at pi, and I've got one over at negative pi. My period for just the cotangent of x, right? If you look up here, cotangent of 1x. So the period here is just going to be pi over 1. So it's pi. So we're going to draw one period from 0 to pi, and another period from on the other side from negative pi back to 0. And this is what it would look like. So when you add in, I'm going to go ahead and add in all the different values, the fourths, and just like we did with sine and cosine, cut it in half. So to go from pi, we cut it in half to get half pi, cut that in half again to get pi over 4, and then find out what's in between the other part. And then we can go ahead, add our amplitude here, although it's not really amplitude. Remember, tangent and cotangent go up and down forever. But we do use the value that we have for k, and we do adjust that for any stretch or shrink we're going to have along the y-axis. I label a couple of points. Remember, we're going to go, it goes from the top left down to the bottom right. This is just the reflection of tangent, and so that's the basic form for cotangent. If you need to go back and pause that, look at it, make sure that you know the differences between tangent and cotangent. Let's do another one and just kind of start off looking at what the basic form would look like if we had 3 cotangent of 2x plus 2. Let's add a vertical shift to that. Okay, period, pi over b. Well, my b is 2, so therefore it's going to be pi over 2. Okay, we don't have a phase shift, but we do have a vertical shift of 2. So one of the first things we can do is we can label our y-axis using the vertical shift. Okay, so I'm going to go on the vertical axis. I'm going to go up to 2. And you can see that I've added a couple more because I know I'm going to have to go up a few, and I'm going to have to go back down a few. So we'll finish that in just a minute. I'm going to put in the asymptotes to kind of give myself a frame. Remember, the asymptotes here are going to act as your beginning and your ending points for your period. So we do the left one and the right one. This is the same as beginning and ending. In my mind, I think left asymptote and right asymptote, so that's kind of why I put that down that way. So we set it equal to 0 and pi, and this is true for everything. Whatever's inside, in this case we had just a 2x right up top, so 2x, we're going to plug that in. 2x equals 0, so anything on the left side is going to be equal to 0, anything on the right side is going to be equal to pi, because that was where my original asymptotes were. Alright, so if we add those, so we went ahead and add the 2 asymptotes, and we're going to place our points here. But remember, and I drew a little red arrow indicating that, remember, this is a vertical shift up 2 units, right? And so when we go up 2, we're going to go over here to 2, and we're going to go up to that next spot because we have, originally we put it on the x-axis, but we have a vertical shift up 2. It just is going to elevate all the points that I used to put, and it's just going to go up 2 times. Right, so you can see that is my center point. And for my center point, I can really already draw the picture. I kind of know what it's going to look like, but we're going to add a couple more points because I do have a little bit of a stretch. And so we're going to go up, using A, we're going to go up A units, which in this case A is 3. So I'm going to go ahead and add those values. And there's the graph. Once you've got your 3 points plus your 2 asymptotes, that's all I need you to put down. Basically, it's 5 different elements that you're going to add to the graph before you can draw the curve in. And I can continue this process. I could go another period. I could go from half pi here, and I could go again and add a half pi, which would get me to pi. And I could draw another picture, and another curve would be just going down just like the one we have here. Take time. Make sure that you know how to graph cotangent and tangent. And there's another video if you haven't seen the tangent video and you're a little confused about the tangent. Go back, watch tangent. And there's also 2 different videos for sine and cosine. One video is the basics. One video is a little bit more when you have phase shift and vertical shift and all that added to it when you're going through some things. Okay? Got any questions? Please re-watch these or ask questions. Shoot me an email, and we'll talk about it later.